In this video, we're going to be talking about solving quadratic equations, and we've learned how to solve quadratic equations by hand using a graph. And so let's just practice that for a moment here, where we have a graph and we are given a quadratic equation. And I know it's a quadratic equation because the highest power here is x squared. So that's how you know if something's a quadratic or makes that parabola or U shape, if it has an x squared in it as the highest exponent. So let's just go over a few things. We can see that this is in standard form. Standard form means that it is in that form where it doesn't have parentheses, but the exponents are in highest order. So we can see that this number here, 1 in front of x squared, is our a, b is that -4 in front of x, and c is the number that is our constant. So it doesn't have an x next to it, it's just a number. And so the beauty of standard form is that c is always your y-intercept. So if I go to this y-axis here, I know it's going to hit it at 3, positive 3. So I already know 1 point on the graph. Actually, let me make that blue. And then from here, I'm going to now find the vertex. Now for vertex for standard form, I need to use that formula. And let's review that formula for the vertex. It's where you have to find x first, and you use the formula -b over 2a. And I'm going to plug in my b, which was that -4. Notice there's a negative already in front of the formula, so this is going to be a -4. This negative came from the formula, and the b also has a negative number, so I'm going to plug that in. And then in the denominator, we have 2 times our a. Our a was 1 here, so I'm going to put that in to our formula. And then we're just going to simplify. So 2 negatives make a +4 for the top, and the bottom is going to be a 2 when I multiply 2 times 1. If I divide 4 divided by 2 is 2. So that means my x value for my vertex is a 2. So keep that in mind. If I know x is 2, I can plug the 2 in for x, solve out for y. So if down below, I'm going to say x is equal to, y is equal to x squared. So 2 squared minus 4 times 2 plus 3. So working this part out, all I've done right now is plug my 2 in for x. And I'm going to find what y is, because then that gives us a coordinate. And I need that coordinate in order to plot that coordinate on the graph, because that's my vertex. All right, let's get to it. So order of operations says that I have to do parentheses first, exponents next, then it's going to be multiplication, then addition and subtraction. So PEMDAS, or please excuse my dear Aunt Sally. So parentheses come first. There's nothing I need to simplify inside the parentheses because it's just a 2 inside. Exponents are next, so I have to take care of this square. So 2 squared is 4. Then this here is just multiplication. 4 times 2 is 8 plus 3. All right, let's combine our numbers here. So we generally combine from left to right. So 4 minus 8 is -4 plus 3 is -1. So I get -1 as my y value. So my vertex here is my x value 2 and my y value -1. So that tells me that my vertex is going to be someplace, let's see, 2 over down 1 right there. So I'm going to plot my vertex here. I'm going to put a little v here to remind me that's the vertex. So the vertex means that it's the middle of the parabola. And so if I were to draw a line of symmetry through the vertex, remember, because the vertex is a middle, this is where the line of symmetry is at x equals 2. That means I can reflect this point over 2. So I can reflect the y-axis or the y-intercept over 2 units. Since this is 2 units to the left, I got to go 2 units to the right to make this parabola as symmetric as possible. And then I'm going to be drawing my u from my vertex to the points that I found. So it looks like this parabola is moving up. Now, what I want to know is the solution to solve for the quadratic. When you're solving for quadratic, you are finding where does it hit the x-axis. So it hits the x-axis, the parabola, at 1 and positive 3. So I have two solutions. So my solutions is at 1 and positive 3s. And that's how you solve for a quadratic using a graph. Now let me just say, this is kind of a little bit tricky here because it's all based on my drawing. If I were to kind of skew my lines a little bit or skew my curves a little bit for the parabola, it might not have touched 1 and 3, right? And so this becomes a little bit tricky to navigate whether I got the correct x values or the correct solutions. And so today we're going to teach you ways how you can algebraically solve for a quadratic equation, meaning you can find the x values that hits the x-axis without using a graph, using algebra where you're solving things out and solving for x. And to do that, we need factoring skills and we need square root skills. But today we're just going to focus on factoring skills. So let's get into it. Solving quadratics by factoring. What you got to do is when we solve for a quadratic, we are looking for x-intercepts. And why are we looking for x-intercepts? Because if we're solving for an equation, generally we're finding x, and all the x's are going to be on the x-axis. And anytime the parabola touches the x-axis, those are x-intercepts. So when you're solving for a quadratic, you're actually finding x-intercepts, or where does the parabola touch the x-axis? In our case, 1 and 3. So to do this, what you have to do is these 3 steps. And the first step is to take your equation. So if this is your quadratic, you're going to make the y equals to 0. So set the y equal to 0, and then you're going to try to solve for the x's by factoring. And then after that, you're going to set the factors. So once you have your factors, you're going to set each factor equal to 0 and solve for x. And I'll show you why you would want to factor. So using this one as our example, you'll notice this equation is the exact equation from our warm-up problem. So I already know that the answer should be close to 1 and 3. So we're going to see if this answer here is going to be pretty close to how I solve it when I use factoring. So let's get started with part A here. So to solve this problem, I need to first set my y equal to 0. So I'm going to make this 0 here. The only thing is I kind of like to write my 0 on the right. It's just a preference style. So oftentimes you're going to see people write the equation, the quadratic, and they'll set the right equal to 0, even though you can set this side equal to 0. It's just a preference. So generally, you'll see it this way. So from here, I've set the equation equal to 0. And now what I'm going to do is factor. So to factor, remember, this is a trinomial. We have to think about what two numbers multiply to give us 3, the constant, and what adds to give me the middle term. So 3 is, limited amount of options. 3 times 1 gives us 3, and that's the only numbers that multiply to give us 3. So when I factor, I got to put my x's down and my constant, so 1 and 3. Now, when I look at this here, I notice this is a positive number, so either they're both positive or they're both negative, so make a positive 3 when you multiply. Now, because the middle term is a negative, I know to make both of these negative. So negative 3 times negative 1 gives me positive 3. Negative 3 plus negative 1 makes a minus 4. So this works. So now that you've basically factored, notice how the power here for the factors is x to the first power, which makes it significantly easier to solve if I were to set both factors equal to 0. So the third step, or the last step here, is just to set each factor equal to 0. Because if all of this went to 0, when you multiply 0 with this factor, it'll end up being 0. If this guy's a 0, then when you multiply by this factor, it'll end up being 0. So that's why we set each factor equal to 0. And now because x is to the first power, it's easier to solve. Whereas x squared, it's a little bit trickier to solve for x squared. So if I add 3 to both sides, I can get rid of the number to get x by itself. So in this case here, if I add 3 over, this would be a 3. 0 plus 3 is 3. So that's my first x value. If I add 1 over for the other factor, I get positive 1. And I want you to notice these two answers here. These two answers are the exact x values when we solve. And turns out our graph did a pretty good job because we also got 1 and 3 on the x-axis. So sometimes graphing does work pretty well. or get you to the exact answer, but not always the case. So let's practice this factoring skill because it really didn't take that much step. It just took us setting it equal to 0, finding the factors, and then solving for x by setting each factor equal to 0. So let's do that here. This one's a little bit tricky because it's a binomial. There's 2 terms. So we're going to set the equation equal to 0. So again, I always like to write the 0 on the right. It's just a style. And from here, we're going to need a factor. Now, you can only factor a binomial if it's a difference of perfect squares. Now, there is a difference. There is a minus sign here. So I think this is factorable. And 1, if you were to think about 2 numbers that multiply to give you 1, well, that's kind of simple here. It's just 1 times 1, right? 1 times 1 equals 1. So I think this is also a perfect square. So if I were to factor, I would have that -1 and a +1. So difference of squares means that you're going to have 2 factors that are opposite sign, but the same numbers that are going to be used. Let's see if this works. So -1 times +1 gives me that -1 that I'm looking for. And when I take -1 and I add it to +1, that cancels, which means that's why there's not a middle term, like there's a middle term here. So this is going to work, and if you are weary of it, then FOIL it out and see if it does give you x squared minus 1. All right, now that we have gotten that factor, I'm going to set each factor equal to 0. Notice how I carry the 0. When I set it equal to 0, I still carry it until I get to the point where I'm solving. So if I am adding 1 over to get 1 or the x by itself, I get x equals +1 as my first answer. And this one, I'm just going to subtract the 1 over. So that cancels, and x equals -1. So it looks like my 2 solutions here is x equals +1 and x equals -1. I also want you to notice that right now I'm getting 2 x values for all of these equations that I've been doing. And I want you to notice, is that going to be the pattern for all quadratics? Am I always going to get 2 solutions, and why is that the case? So I want you to start thinking about that now. So let's progress into example 2. So example 2, I made this even easier for you guys. What if it's already factored for you and you just have to solve for the equation? So everything's been factored, and we just have to get the variable by itself. So in our case, I just have to do basically step 3. I just have to set them equal to 0, the factors equal to 0. If I were to do that, I would just subtract over the 1 for the first one, so x equals -1, and I would add 5 over to the other side, and so k is equal to +5. All right, let's get down to our next one here. This one, we have more numbers in front of our variable, so let's see how we would handle that. But we're still going to take each factor, set them equal to 0. But when we're trying to get the variable by itself, the m, we want to move the thing that's the furthest away. So this 2 is next to the m, so I don't want to move that yet. But this 3 is a little bit further away, so I'll move the 3 over. So generally, you want to move the thing that's further away. So like the 3 can be subtracted off. 2m drops down, you have a -3. If I divide by 2, that comes off. M is equal to -3 over 2, or you can write this as -1.5 if you change it to a decimal, but I'll just keep it as a fraction. Less calculator work for me. This one here, the m is right here, so I need to move over the 3 before I can move over the 4. So 4m equals -3. If I divide by 4 to get rid of this multiplication, that would give me m equals -3 over 4. And that is my 2 variables. So I have 2 solutions here as well. All right, into example 3 here. This is where we're taking a quadratic equation again. But notice how this time the other side is not like a 0. In fact, it's like some number, right? And when we're dealing with the situation, in order to solve, we got to make one side equal to 0. So what we do is we'll move it to the other side to make this side a 0. So notice the trinomial is sitting here. If I move this 5 over, I could add it over to the other side to cancel that part out to make it a 0. If I add 5 to the other side, I have to add it to the 19 because the 19 here is the only thing that's a number. This is an x and this is an x squared. I can't combine those terms. So I'm only going to add it to the 19. So that cancels. I'm going to bring down my equation. So this is now 0. X squared minus 11x comes down. 19 plus 5 gives me 24. And there we go. Now this looks like a trinomial that's been set equal to 0. And so now I can go ahead and solve the equation and get x by itself. So now I have to think about factoring. Two numbers that multiply to give me 24 and 11. Let's brainstorm here. So we have, there is 2 times 12. Now that won't be any good because 2 plus 12 is 14 and 2 minus 12 is 10, so not 11. 3 times 8, if I add 3 with 8, I do get 11. So this might be the winner here. So I'm going to try this out, and if it doesn't work, I'll go back to the drawing board. So put my x's down, I'll put the 8 and the 3 down. Now what I notice is that this number here, 24, is a positive. So that means either both of these are both positive or both negatives. Now because the 11's a negative, I need this to both be negatives. So let's see if this works. Negative 8 times negative 3 does give me positive 4, but negative 8 plus negative 3 gives me a negative 11, so this works. And now once I have my factors, I'm just going to set them equal to 0, and then move over the numbers to get x by itself. So I'm going to move over 8 by adding, and so my x is equal to positive 8 for the first one. If I move over 3 by adding, my x is equal to positive 3. And so here are my two solutions. It means that when if I were to graph this on the, if I were to graph actually this trinomial here on a coordinate system, that means the parabola would touch it at 8 and 3. All right, this one here is very similar to this problem. Again, this side is not 0, so I'm going to try to move everything to one side so the trinomial can be all together. So the 3 terms can be all together. So if I add over 7, that will cancel it out, but I have to add 7 to the other side. So this cancels. I know my right side is 0 now, but I want you to notice that this is a constant. 7 is a constant, so it doesn't combine necessarily with the r to the first power or r to the second power. So I'll just put it to the side, like put it next to it. So I have 7r squared minus 14r, and I'm just going to put the 7 next to it, and it looks like a trinomial when I do that. And so I have 3 terms to work with now. And what I also notice is I could use slide and divide to try to factor this. I could do it. So I can work this out, slide and divide. But what I notice is that all of them, these numbers, are divisible by 7. If you notice this, you don't have to use slide and divide. You can divide each component by 7. So if I divide this side by 7, I have to divide the other side by 7. But be very careful. When you divide something by a number, you have to divide every term by that number. So if I were to walk through this, 7 divided by 7 is 1r squared, or you don't need to write a 1 in front of a variable because it's just itself. So I'm just going to erase that. Negative 14 divided by 7 is negative 2. And I'll bring down the r. And then 7 divided by 7 is just a 1. And 0 on top divided by 7 is going to be 0. So we really didn't do anything to the other side when you're divided by 7. From here I can factor. Thinking about two numbers that multiply to give me 1, there's only one option, 1 times 1. So this has to be it. So I'll drop down my r's, put down my 1's. Now, again, this is a positive sign, so they're going to be either both positive or both negative, but we can see the middle term's a negative, so they have to be both negatives. So if I set them both equal to 0, notice how the factors are the same. So if I add 1 to both sides for each of these, I'll get both r equals 1. So I still get 2 solutions, right? I still get 2r that come out, but they just happen to be the same solution. So when we look at all the ones that we have factored so far, we can see that when you have a quadratic, you always get 2 solutions. And sometimes they can be the same, or sometimes they can be totally different. All right, that's it for this video. In the next video, we'll talk about solving with square roots.